Hello everyone. Today we're going to look at scientific notation. First, let's define what it is. Let's have a number, n. n is greater than or equal to 1, but smaller than 10. And it is multiplied by an integer number of 10. Let's call that a. A can be positive or negative or 0. So we can see that this is good for very big and very small numbers, because a can be a large number or a very small number. So let's have a look at some numbers. Let's say this, and this. Now, to convert these into scientific notation, 1237 becomes 1.237. Remember, our number n is between 1 and 10. So 1.237 multiplied by 10 to what? We've just moved the decimal place. The decimal place was originally here, and we've moved it 1, 2, 3 places to the left, so we put a 3 in there. In the same way, what we've done here, this is 10, a power of 10 larger. We've moved the decimal place 1, 2, 3, 4 decimal places, so 1.237 times 10 to the 4. Here, because we want our number to be between 1 and 10, we would write 1.237 multiplied by 10 to the negative 1, because we've moved the decimal place to the right. So when we go to the right, we have a negative, and when we go to the left, it's positive. Okay, now let's do it the other way around. We have some numbers in standard form already. Standard form, scientific notation. These are the same. So what do we do with this? If we're going to express these numbers in natural numbers rather than scientific notation, if we're going to express these numbers normally instead of in scientific notation, what do? Well, we have the decimal point here, and we've got a 2 here. So basically we're making this number larger by moving the decimal point to the right. So we would have 491.7. because we've moved it 2 spaces. 2 here, 2 spaces. In the same way, we've got the 3 here, so we would move this decimal point 3 spaces over. 1, 2, 3. So we have 3,794. Now here we've got a negative. So we don't move the decimal place to the right, we move it to the left. So we would have a 0, and we would have 9214 over here. So let's see how many spaces we need to move it. So it's originally here, so that's 1 space, 2 spaces, 3 spaces, 4 spaces. So we would have a point here and here. We've moved 1, 2, 3, 4 spaces. So this is the normal way of writing this number in standard form in scientific notation. So you see, scientific notation is much easier when we're representing very small or very big numbers. Let's do another one for practice. we've got 6.4 times 10 to the negative 2, so we'll have 64 here, and we'll have a 0 here with a decimal point, and we would move the decimal point 2 spaces, so 1, 2, and just put a 0 in there. Here is a quick side point worth knowing. You probably know already that 10 to the 0 is equal to 1. Any number to the power of 0 is equal to 1. So if you have, say, this number, this is in standard form. So what you've got is 4.2 times 1 is equal to 4.2. If you're asked for an answer in standard form, and this is your value, then this is what you need to write, times 10 to the 0. It's the equivalent to 4.2 times 1. Okay. Now let's do some calculations using scientific notation. Let's say 2,100 multiplied by 19,000. Now, your first task is to get these into standard form, which is 2.1 times 10 to the third power, because we've moved it 1, 2, 3 spaces, multiplied by 1.9 times 10 to the 1, 2, 3, fourth power. Fourth power. So now what we do with this is we multiply the numbers between 1 and 10. So we have 2.1 multiplied by 1.9 raised to the power of what? Now if you remember your index laws, a to the n multiplied by a to the m is equal to a to the n plus m. So we've got 10 cubed and 10 to the fourth, which is equal to 2.1 times 1.9 multiplied by 10 to the 7th power, 3 plus 4. So our answer is 3.99 times 10 to the 7th. Okay, let's see what happens when we're adding and subtracting in standard form. First, let's write our rule over here. If we move the decimal place to the left, then we add to the exponent. If we move it to the right, then we subtract from the exponent. So let's say we have 1.6 times 10 squared plus 2.3 times 10 cubed. Now, because these powers of 10 are not the same, we can't add these directly because they actually represent different numbers. So we need to make the powers of 10 the same. We could either do this one or this one. Let's do this one. So because we are adding to this, we need to move the decimal place to the left. So we have 0.16 times 10 cubed. We've added one, so we move the decimal place one spot over. Now we can add these numbers as we would normally. So 2.3 plus 0.16 is 2.46. We multiply this by 10 cubed because we don't need to do anything with the exponents. We've added these numbers, and this is equal to 2,460 in normal form, because we've just moved this over 3 spaces. 1, 2, 3. Our 0 would go in here, and there's the 3 spaces we've moved it. So this is our answer. I hope you enjoyed the video. If you did, subscribe, like, comment and share. Bye.